Hey folks, Little J, the RideShareGoober here. Today's pearl snap of wisdom: I'm not wearing a bolo tie, dressed for work, because we're going to be getting our hands dirty. I use a lot of equipment to do my job when I'm driving rideshare, and I'll give you a little tour of that, tell you about that equipment in another video in more detail, but just a quick walkthrough. If we start from the passenger point of view here, I have an Octopus tablet. And I have a tablet that I use for my passenger camera. I have a wireless charger. I have an Amazon Echo Dot. I have a wireless hotspot. Underneath, I have my dash cam. And of course, we have the passenger camera itself. And I like to have these things powered all the time, not just when the engine is running. I added a circuit to my fuse block to power all that equipment that was powered all the time. Because I like having my dash cam going. It points in both directions, can get anybody tampering with the car when I'm not driving while it's parked. Same thing for my overhead camera, and of course I like to have my Wi-Fi hotspot powered all the time to keep it charged. And even though each of these is a really tiny, insignificant amount of power, the sum total of them was death by a million pinpricks for the battery. I was coming out for work and finding my battery dead. Even just after 8 or 10 hours of the car being parked, my battery was run down. And so we're going to have to add some auxiliary power. This is useful not just for rideshare drivers. This is for anybody who needs extra power in their car. This is for radio operators. This is if you have a motorhome. This is how your house battery works. Rideshare drivers obviously are going to have great use for this. What we're going to be doing today is adding an auxiliary battery that's going to power everything when the car is off but is disconnected from the car battery. And then when we start the car, it's going to close a relay, and that is going to connect the auxiliary battery to the alternator, charge the auxiliary battery while the car is running. And of course all the devices are powered by the alternator when the car is running. Okay, so the materials we're going to be using to do this job. I have a pair of lead acid batteries. Moving closer so you can zoom in here. I have lead acid batteries out of a computer UPS that had its inverter get damaged. And as you can see, these batteries are wired in series right now for 24 volts. We're going to convert these to parallel for 12 volts. Actually, one battery would probably be enough. If you had a lot more power than me, you would obviously need a bigger battery and a larger charging system, but this is pretty small for a lot of small devices. All right, we're also going to need a main fuse. I'm using a 30 amp because we're not going to draw anywhere near 30 amps. I've had it all on a 10 amp circuit all this time. I got some 14 gauge primary wire. If you're dealing with a big deep cycle battery, you're going to need something like a 4 gauge. This is going to be the relay for isolating it. You can use a diode isolator. There's nothing wrong with that, but you get voltage drops and issues like that with a diode isolator. Relay isolators are always a better idea. That's what you find in big systems like boats and motorhomes. Then just to make life easier, in the wiring part, I did buy a socket for the relay. You don't need that. All these can be had at your local parts house. And here's my messy assortment of crimps and my crimpers that we're going to be using, and some smaller primary wire from another project. Whenever you're working on anything electrical in your car, step one, disconnect the negative lug from the battery. Always. I mean, even if it's something small and something minor, you would not want to just accidentally touch an exposed piece of wire to some bare metal in the car. Get yourself a dead short, hurt yourself, cause a fire, even if it just blows a fuse. Worst case scenario, you go poking around in the wrong place in there, you could accidentally deploy your airbag. So always disconnect the negative battery cable first. First thing I need to do is take out my old circuit that I added. And all that was a little fuse tap. One of these devices that you plug in place of a fuse. You put a fuse for the existing circuit, and then you add another fuse for your new circuit. So I'm going to take that out and remove one of these fuses and put it back in for that existing circuit. And then we need to remove these panels where all of my wiring is. Now, this wire is running through the dash down here to a power distribution block that has some USB and cigarette lighter ports. I will show that in a few minutes. Right now we're taking our existing circuit out, which is right here. So my power center actually had blue and brown for its wiring instead of red and black. We had to figure out which was positive and negative on that. The blue was a negative. You can see we have it grounded to the chassis here. This is our positive coming in from the circuit. So let's remove this old circuit. And I have this routed to make sure that it is not crossing anything, any moving parts, like the park and brake pedal or the steering column. So we may have to be creative getting it out, just like we're going to be creative getting the new wire in. All right, there's the old circuit. You see I used some pretty lightweight primary wire, but I mean it's on a 10 amp fuse, maybe a little bit low, but I wasn't pulling anywhere near the 10 amps, so it was fine. Okay, before we go on, a quick lesson in how a relay works and how it can be used as an isolator. You have 4 pins on here. Some of them will have 5 pins for a normally closed contact, but we'll talk about that in a moment. But these pins are going to be labeled 85, 86, 87, and 30. And the way it works is pins 85 and 86 go to a coil, a 12-volt coil, and pins 87 and 30 are kind of like a switch that's turned off. Whenever you get 12 volts between pins 85 and 86, that will energize that coil and it will close the switch, completing a circuit between pins 30 and 87. So what we're going to do on my handy socket, pins 30 and 87 are blue and yellow. We're going to run one side to the fuse and to the battery. The other side is going to go to our auxiliary battery and our power distribution center. Okay, now we got all the components prepped. I've done some stripping, got my crimp connectors and my primary wire all ready here, as well as the fuse. Now, one thing that a lot of people don't think of is that if you are adding a device to a boat, a motorhome, a car, whatever, and you are connecting directly to the battery, you should have a fuse as close to the battery as possible. You don't want it close to the device you're adding, because if something goes wrong, a wire gets frayed, melted, whatever, and you get a dead short somewhere between the battery and the fuse, there's no protection. You're just going to blow up your battery and start a fire. So the fuse should always be the first thing in line. Now my crimp connectors have been in that case for a while, so they're pretty dirty. I kind of polished this up some with a rasp, try and make it cleaner, make sure my connection is solid, and give it a good solid crimp here. Whenever you finish a crimp, you should give it a good solid tug to make sure you crimped it in good. Of course, when you're stripping your wire, always be careful not to cut any of the strands off or break any of the strands off. Those are actually there for conducting electricity. You want them there. and we're all set to connect it to the battery. All right, ready to connect it to the battery. Again, we have to have the ground disconnected to make sure that what we're doing here is safe, because now we can touch any part of the chassis with this wire while we're working and not have to worry about creating a dead short. Yeah, I think everything there could use a little cleanup. Although when it was running my battery down, I did clean inside the post and inside the terminal to make sure I was getting a good connection while it charged. I'm going to be sure to bend this out of the way so that I can take my caps off and check the water in my battery anytime I need. And snap it closed again. Okay, so we checked beforehand. You're going to need a source of power that will energize that coil only when the key is on. So we need a source of power somewhere in the car that isn't powered when the key is off, but is powered when the key is on. Now, a great place to look is in the fuse block under the hood. We checked every single circuit under the hood. There's nothing there we can tap off of that's going to have power or be not powered when the key is off. Everything there is powered around the clock. So we're going to have a little bit of extra work to do. In the fuse block, we have a 10 amp circuit here that is powered off when the engine is not running, but does have power when the engine is running. We're going to repurpose our fuse tap to use that circuit. Take that 10 amp fuse out, add it in here. This 10 amp fuse is going to replace it, and then we're going to have a 10 amp circuit to energize that coil. It's a very small load. It's not going to be creating a lot of extra load on the circuit. That's the purpose of the relay. Most cars have a useful little tool to make taking the fuse out easier. Of course, I chose one that's hard to reach, but easy to remember. And if you need to, you can use a needle nose or something like that. And this is going to run to the relay coil. And we're going to have to run a primary wire from the relay coil to right here and crimp it. Okay, well, as it would be, the grommet in the firewall of a 2014 Infiniti is very hard to find and hard to get to. Hopefully your car is easier. If your car is one of those that doesn't have any grommets and you need to drill a hole through the firewall, make sure you're not drilling into anything important on either side of that firewall, and be sure you put a grommet. Don't just leave a bare wire against that raw metal where you drilled the hole. I've got a fish tape routed through here, 2 pieces of primary wire connected to it. One's going to be for the relay coil and one is going to be for the relay normally open contact. And we're going to be able to pull it through the grommet as I run here. And here's the other end of my fish tape. Two primary wires. All right, here's the primary wire that's going to be going to the coil of the relay. I have routed it safely away from any moving parts, particularly the park and brake pedal linkage, and to the fuse block where we're going to be using this auxiliary circuit. And we're going to connect that up. Now honestly, I didn't need to use this larger wire for the coil. That's the purpose of the coil. It uses very little power. We could have used some smaller wire, but I had plenty of this larger wire. And my videographer has a cough. There we go. And if I measured that circuit properly when I checked it before we disconnected the battery, this will only be hot when the key is on. And plug it back in. It's dark now. We're losing daylight fast, so I need to get a flashlight to get that plugged in. There it is. And we can put the fuse panel back. And as you can see, I have another wire hanging down that I've also run. This is going to be the one charging our battery. Alright, we've selected a safe path to go from the grommet in the firewall around the PCM to here. We're going to mount the relay right there on this mounting bracket for the PCM because it's safe to run a screw in there without harming anything. This one right here is going to be the primary wire for the coil, so we need to cut that down to length and then crimp it to the socket as well. Nice clean strip, didn't lose any strands. And this one's going to need to go to a chassis ground, which we're going to have to check for ground in a few spots here with our meter. I don't like the one on that battery bracket I was just pointing to. I'll find a better one than that. It never hurts to check your relay to see if the two sides of the coil are actually marked positive and negative, but in most of these little 30 amp automotive relays, they're not. You can connect it either way and the coil will energize. Now, since we're going to be mounting it down here, you know what? This bolt here is going to a metal bracket and it's probably a really good ground. So we can ground it right next to the socket. We'll double check it with a little continuity check against the negative lead. Negative battery cable. Bolt. That's a good solid ground. So we'll put a ring lug in here. Oh, we don't want those strands to get away. Solid ground is also important. Give that an extra crimp because I don't like the way some of those strands splayed out. Looks like a 10mm to me. And we'll tie wrap these like that, and it'll be beautiful. So let's work on the battery. Okay, after some measuring, we're not going to be able to fit both batteries under the console. I would prefer to have two, but really one will get the job done. And these batteries are perfectly safe for using inside the car. They're safe to use in an office. Like I said, it came out of a UPS. So we're going to start getting wired up here. As you can see, this is my power center that I keep hidden in the console. It's got 3 cigarette lighter sockets, 2 2.4 amp USB sockets, and 2 1 amp USB sockets. And these aren't worth much. Obviously, they can't power much. They can charge something in a pinch. And there's a loud car going by. So what we need to do at this point is I'm going to use these protected terminals that have a little plastic shroud around them for the battery connections to make sure that nothing ends up getting too close. But these are very small, and we're going to have a hard time getting 2 wires in there for the hot side, because we're going to have the power coming in from the relay and the power going out to here. So what we're going to do is make a small jumper. It will make it easier to wire up when we're working under the dash anyway. Forgive the lighting, we've lost our daylight. And of course we need a ground for the battery. It's going to go to the same place that the power center is being grounded. This is a little bit longer than we need, so we'll cut maybe 6 inches or a foot off of there. And my ring lug for my ground just happens to be a blue butt, which is a little bit, or a blue crimp, which is a little bit big for this wire, so we're going to double it up to make sure we get a good solid crimp. very careful attention to polarity lest we start a fire with this battery or the car battery. Mash these down, and then we're going to tape these in place to make sure that they don't come off. Or get shorted, or anything else disastrously bad that can happen. And one more strip to do, which is the hot side of our power. And as you can see, even with all the devices that will be connected, they felt just fine with number 16 wire. And the wire coming from the relay normally open contact, pin number 87 or 30, is going to go in here with this. We could just as easily use a piggyback on here, I suppose, but I didn't have any piggybacks. As you can see, this tangle is the power wires from our devices. The battery is going to go, if you can angle the camera down this way, the drop light's not getting good light. We have a cable here, you're going to have to come around to the left. There's a cable here for the shifter. I obviously don't want the battery interfering with the shifter. So that's why we can't fit both batteries in there, but one battery fits very nicely right here, and the power center can go on the other side in between these brackets. Like so. And the battery is going to live in here. Take the camera. And as it would be, it has a very nice snug fit, especially after I put this panel back on. I'm not concerned at all about that battery getting moved, bumped, jostled, or bounced out of place. So let's go ahead and connect our grounds up. And move the camera down a little bit right here. As you can see, I've already removed the nut where the power center was grounded. And we're going to add our battery ground on there with it. And I'm going to put some foam, some neoprene or something under here to protect those so they're not rubbing against that metal bracket, even though they're just grounds. It's okay if they short to that. Okay. This is our hot wire, which I now need to route under the dash. Okay, with that wire safely routed, power to the power distribution center, power from the alternator when the relay is engaged. And I don't like doing this way. Sometimes you just gotta run what you brung. and I missed. Let's get that lined up a little bit better and give it another crimp. And you can see some exposed copper there. So this is going to get taped up. Okay. Alright, this mad tangle is all our devices. They're going to go to the power center. Some of them we can get plugged in right now. I really love the cigarette lighter adapter for my dash cam because it has a piggyback built into it to power another device. I'm using this three-way because I have so many devices that are not cigarette lighter adapters. And this particular three-way is a very high capacity one. And then the last one to get plugged in is actually only accessible from the other side because the wire is just barely long enough. That's the one to the Octopus going to the back seat. And hopefully we can get this to pass through here. I'm down here so I get more light here where I'm working. May have to take the battery out and put it back. And of course we have a lot of extra length from some of these wires because they're only running 10 inches. And this one right here is our Wi-Fi hotspot that's stashed back up in there. I'm not real happy with how messy it is under here, but I am confident that it's safe. Okay. We may end up with a lot of shadow here because the light is on the wrong side. Get your light shining right in here. Power center is right here. And we're going to plug in the Octopus. There, we got some slack, so I have to worry about it wobbling out. And put this one back in. And this one, of course, attaches by a different method. It's got a pin that needs to be lined up at the front. That's it. Well, it seems that my videographer, in changing phones after her battery went down, was taking stills when she thought she was taking video. So you missed the final installation of the relay, and as it would be when I was installing the relay, I cracked the housing. So I'm going to have to get a new relay, but the beautiful part of these sockets and these relays is that they're universal. It's a design made by Bosch a long time ago. And I was going to tape the relay onto the socket anyway, so I've got the housing taped onto the relay for the time being until I get a new relay, and it's tie wrapped into place for the moment. It's going to get screwed to the hole we made down there in the bracket. As you can see, we have our 30 amp fuse, which we're not going to draw anywhere near that. That's going to be just in a crisis that it gets to 30 amps. And we have the power coming from the circuit we added in the fuse block. That's only powered when the key is on, which is energizing the relay, which it is right now because it's running. And the other one is going to the auxiliary battery to charge it. And because that battery is dead, right now that's also the only thing powering all my devices. Once that battery is charged up, my devices will stay powered even when the engine's not running. And here's our finished result with the engine running. Passenger camera tablet is charging. Wireless charger. We can drop in my videographer's dead phone. Charging. Alexa, open the pod bay doors.
I'm sorry, Dave. I'm afraid I can't do that. I'm not Hal and we're not in space.
Yep, she's feeling sassy. Dash cam working. Passenger camera working, which we obviously could see right here. Now that's interesting. My passenger camera, when it's in night mode and has its infrared emitters on, looks like it's glowing purple on a camera. And we also have the charger for the sign, which I have a quick connect on, and it probably needs a charge because it was getting used last night. And it's got power. Special thanks to little Megan for being a videographer today. Time for me to take a shower, shave, pop smoke, and go hit the road. Remember, the Bolo makes it better. If you have any questions, put them in the comments below. I'll help you out any way I can.